Hey, it's Dr. Mike T. Nelson here, back with another Flex Diet podcast for you. And today I have a very special guest, my good friend, Dr. Doug. Whenever I have questions about omega-3 or fish oil testing, or pretty much anything on the history of omega-3s, essential fats, omega-6, Dr. Doug is my go-to person in that area. I first met him at the ISSN conference, so International Society of Sports Nutrition, almost a decade ago, and I've been using his omega-3 test with my online M3 clients pretty much since that time, and it's been extremely useful. So you want to listen to the end of this podcast. I have a crazy offer that he has on the omega-3 test, which is great. And in this podcast, we talk all about omega-3 fish oil from their use in native cultures, the Inuit, the Eskimos, and even some new stuff on possibly reducing the risk for COVID. So we go across the whole spectrum here on omega-3, which is a question I get a lot about fish oils. And I still see some people who are lower on fish oil. So even if you're using it as a supplement, probably still worth listening to this podcast, which is brought to you by the Flex Diet certification. Go to flexdiet.com, FLEXDIET.com. You'll be able to get onto the wait list there, which will put you on the free newsletter. And we'll let you know the next time that opens up. We've got a whole section in the Flex Diet on essential fatty acids, the role of omega-3, omega-6, what you need to know about fatty acids and lipids themselves, and even a little short version in there about some of the testing. So enjoy this podcast with my good friend, Dr. Doug. Hey, what's going on? I'm here today with my good buddy, Dr. Doug. How are you today, sir?
Hey, great, Mike. Nice to see you.
Yeah. Good to see you again. I know you're holed up here in Minnesota too and surviving the cold, so that's good.
Yeah, my electrons are still moving, so that's
Yeah.
a good thing.
It's always a positive.
Pretty cold, yeah.
Yeah. So for people who may not know you, do you want to give us just the short background there? Because you do a lot of very fascinating stuff with omega-3 testing, lipid testing, consulting. We're talking about some consulting stuff with military personnel, industry, all sorts of stuff.
Yeah. I work with fatty acids and lipids, and I've been trained at the University of Minnesota with a guy named Ralph Holman. He's the guy that invented the term omega-3s and really inspired me to get people to eat omega-3 fats. So I've been on a 30-plus year quest now to do that. I have a small company called Lipid Labs, and we do fatty acid testing and consulting for food and pharma, and we have this omega-3 blood test that we offer too. That's a way of assessing fatty acid status. Done a lot of different types of research. Lipids are really involved in so many different avenues of life. So our other lab does a lot of work with pharma companies that produce drugs, protein-based drugs with fermentation. So the fatty acid cocktail that goes into making those proteins is really important, how well that biomass grows. So that's actually a big part of what we do. So, and if you can get a 10 or 20% efficiency in a bioreactor that's worth several $1 million, it's a big, financial advantage. But we've worked with, I helped develop omega-3 eggs a long time ago. There was a few others working on it. So forward foodifications with omega-3s. We got flaxseed into pet foods and started looking at omega-3 metabolism in dogs back in the 90s, and that kind of ushered in the craze of using long chain omega-3s for pet foods. So particularly proud of that. So but yeah, I'm still affiliated with the University of Minnesota. I was a long-time employee there, and run a private company now, and just love chatting omega-3s and keeping people healthy, and we work with a broad spectrum of folks. So. Good to talk to you today, too.
Yeah. We first met, I think, 2010 at the ISSN conference. Is that right?
Meeting. Yeah, it was a great meeting. Yeah.
Yeah.
Yep.
Yeah, that was fun.
I think I saw you out running at 5 a.m. It was probably the first.
Yeah.
Joking. So,
Yeah.
but yeah, that was a great meeting, and yeah, a lot of like-minded people there, which was really cool, real practical, and you know, traditional science can be a little stuffy sometimes, but most fatty acid people are pretty cool, though. I'll tell you that. So
yeah, it's a little difference between the ISSN meeting. I think I saw you get an experimental biology a couple times, so little difference in meetings there.
Real formal, 20,000 people. But
yeah. So most people probably know what essential fatty acids are and EPA and DHA, but if you were to give us just a short, like 2 to 5 minute primer on that, just to get maybe some new listeners up to speed on that. Yeah,
sure. So we have fat in our diet is essential. Scientists at the University of Minnesota in the 20s stopped feeding fat to animals, and they didn't grow very well, and they had a lot of skin problems, and they said, oh, there's something in fat that's important, and they figured out, they deduced that it was omega-6 and omega-3 fats. My boss actually at the time, Ralph Holman, was the guy that figured out what the omega-3s and omega-6s were at that time. So, and so they're the 18 carbon ones, and we find those in nature. Those are soybean oil and seed oils, and actually those are concentrated sources, but there's plant-based sources as well. Vegetables have, leafy greens have a little bit of fat, and they have quite a bit of polyunsaturation as omega-6 and omega-3. And then we derive long-chain fatty acids like EPA and DHA. Those are 2 types of omega-3s, largely from marine sources. There's bits in poultry and chicken and a little bit in beef, but those are the long-chain ones. When we say omega-3 family, there's like 5 or 6 different omega-3 isomers. So the main ones are that plant-based one, ALA, flax, walnut, are discernible sources of that, and then EPA and DHA are the 2 long-chain ones. There's one called DPA, too, that's pretty cool. That's always in fish oil. But our bodies use long-chain omega-3s and omega-6s to create membranes, and then we also generate our immune system from essential fats. Arachidonic acid is the big omega-6 one. Always thought that'd be a good name for a band. And,
yeah, there you go. That's pretty good.
Yeah. So, but it's converted with COX-2 enzymes and lipoxygenase enzymes into the hormone-like compounds that regulate our immune function. And that's the one that's considered to be inflammatory, if you will. Really important. We need it, definitely. But a lot of omega-6 in the absence of omega-3 tends to promote an immune response that is maybe too much of an inflammatory nature. So adding omega-3s to the diet helps balance that. And lots of studies that we've done and others have demonstrated that people in North America really don't eat a whole lot of omega-3 compared to other populations around the world. And there's health detractions based on that. So, and in particular, just eating a fatty serving of fish a couple times a week gives you a whole lot of protection for a healthy heart and reduced risks of atherosclerosis. So it doesn't take a ton, but not eating those omega-3s has important implications in human health. So, and inflammation is one of them. Right now we've learned about, in the media, we've talked a lot about COVID, obviously, and the cytokine storm.
Yeah.
So inflammation is what I actually did my PhD on, looking at sepsis. And we also looked at adult respiratory distress syndrome in patients.
Oh, interesting.
But study that hyperinflammatory state in humans and also animals, and then looked at nutritional interventions to try to change outcomes in those populations.
And what did you find with that? Obviously, we're just sort of speculating, but right. Interesting.
We had a animal model that had about a 30% mortality rate. We'd infect them with a bacteria and 2 types of bacteria that were similar in the septic shock seen in humans. But animals getting fish oil didn't die. They did not die. But the animals getting a controlled diet died about 30 to 40%. And then animals getting corn oil, which is a rich source of omega-6 fats, they were like 60 to 80% mortality in there.
Oh, so wow. That's a big difference.
So, yeah. And so this was an animal model, but in animal models, obviously you have an opportunity to pre-treat animals. So the clinical trials in humans didn't have much of an effect on mortality, and it's because you were trying to intervene after the fact, really. And
Okay.
So once this storm and this fire starts, it's difficult if there's a lot of dry firewood there to abrogate that response. So, but the clinical trial that we did was with Impact. It was called Impact. It was an enteral formula that had fish oil, glutamine, and a couple other components. But they did see no differences in mortality, but they did see significant reductions in infectious complications, and mean hospital stay length was about 25 to 30% shorter. So people got out
nice.
of the ICU. Right. So that's ICU capacity is another topic that's
Sure.
very in vogue these days with the demands.
Saves hospitals money too.
Right. Exactly. So people that got these added nutrients got better. And that was really, the animals showed me that, man, in diet's really important to weather the storm of being ill or prevent illness. And in one, that diet was really important. So, and we're kind of seeing that today with COVID. There's been a lot of people talking about the potential for various nutrients in COVID and having a strong immune system, vitamin D and zinc and omega-3 fats. And then there was a paper we talked about a little bit.
Yeah.
It was published, I think it was out of UCLA maybe a month ago. But they measured actual blood levels of omega-3 in patients in the Los Angeles area. And it was a smaller study. It was like 100 folks, but they saw a 75% reduction in risk for people with the highest blood levels of omega-3 versus the lowest 3 quartiles. So it was a big difference. Yeah. And that higher group was older. Their mean age was 76 or 77 years old. And the previous or the lower quartiles in terms of their omega-3 status were around 70 years old. So older people did well, potentially because they had more omega-3 in their blood. And,
do you know what the omega-3 levels were? I mean, were they like sky high, or were they higher than the normal population?
They weren't. It was omega-3 index, so that's the EPA and DHA in red cells. They were, I think the fourth quartile was higher than 5.7%, so around 6% and higher. And,
so high, but not like
but
that's
not
crazy high.
But not like you or I, or some of our friends. And that's the thing. Just having some fish in your diet or a dietary fish oil is just so potentially so powerful, and that can be as simple. It can be a nice salmon meal or trout, something like that. But it can also be a can of sardines that have about 1.25 grams of EPA and DHA a couple times a week that will put you into that protection zone. So people we work with tend to like to see them higher. We measure blood levels of EPA and DHA, and we do this HUFA test that is the precursors for all this inflammatory stuff, and we want to see that quite a bit higher. So we recommend about 2,000 milligrams a day of EPA and DHA to hit those numbers for people living in North America. So
yeah, and that's not that high. I mean, I've speculated that like 2 to 3 grams a day, if you were on the lower end of the spectrum, you're probably going to be okay. And again, obviously, if you can get testing and work with your physician and have more info, that's going to be better. But, I'm also trying to be realistic because most people are like, whoa, like, where should I be?
Yeah, and we see, we have a little questionnaire that goes with our blood spot test, and just ask people really for them to reflect on it, but for us to have a view to it. How much fish do you eat? How much fish oil, or are you taking any kind of omega-3 supplements? And a lot of people respond, I'm taking that supplement 1 to 2 times a week, which means they're probably taking it every other week.
Yeah.
And it's fine to miss days. It's a fat-soluble nutrient, but you just up your dose to give you what you need, over that week period or average for each day. So, so I know, triglyceride reduction works great, 4,000 milligrams a day. And then there's been some omega-3 drug studies where they've had purified EPA that are classified as drugs that have been, about 4 grams a day for those medications. They're derived from fish still, but they're purified EPA. They see big reductions in triglycerides. And then the big study by one of these companies demonstrated a very large reduction in risk after you've had a heart attack for medical complications related to heart. health. So that's out in the marketplace today. But so yeah, it's real, and part of that basis is, looking at your membranes. That's where your fat-based immune response emanates from, and so you want to have in your phospholipids, you want to try to have equal representation of arachidonic acid and EPA and DHA, and that's sometimes referred to as a ratio. A lot of people are 10 to 15 to 1, that ratio in those membranes, and you want to bring it down less than 5 to 1. So when a signal comes in, immune response signal comes in and says, hey, we need some of this PGE2 or thromboxane to fight this battle, your enzyme is seeing just as much omega-3 as it is arachidonic acid or omega-6, and that omega-3 has a much lower emphasis on producing an inflammatory response than the arachidonic acid. So,
and are you looking at the ratio from your testing of the arachidonic acid in the blood compared to the RBC level, or are you comparing that to the blood level of EPA and DHA?
We measure with the home collection kit, it's whole blood, but all the equations, the multiple publications have mapped out equations for establishing equivalencies between whole blood and red cells and plasma and red cells. So that's kind of what the industry bases all that on. So,
and do you find, well, what I've seen just looking at various amounts of your testing is that unless it's a really weird case, and again, I tend to see healthier people, I don't see sky-high levels of arachidonic acid, but I do surprisingly still see some people who are very low in omega-3, especially EPA and DHA, which to me is still kind of surprising.
Yeah, there's been enough information out there, and your audience is really attuned to performance and nutrition. And this is one of the easy ones, to enrich your diet with. We know arachidonic acid. You feed humans about 0.5% energy linoleic acid, and they max out their arachidonic acid, and that's our hint that fatty acid is really important to human health and pathology, and without it we die, obviously. But and same for omega-3s, they increase rapidly too. American diet has about 10% energy right now as linoleic acid, so we're eating quite a bit more than we potentially need for that. But that's a highly debated topic, and good arguments either way. So
yeah, and I'm sure you're familiar with the sports supplement realm. There's actually a supplement that is pure arachidonic acid that has been used, and it has a couple of studies that are, I would say, interesting. I know a good friend of ours, he did some experimenting with it and didn't see a huge difference, again, an N of 1, but any thoughts on that as a sports supplement, or people are high in it, so they don't probably need to add it, or?
Yeah, there was, well, it's all individualized, I guess, and I'm not against it, obviously. Gary Nelson did a study a long time ago, a metabolic ward in San Francisco, feeding purified arachidonic acid, and saw a lot of these inflammatory mediators skyrocket. So there was a little concern at that time with small children, giving them a lot of arachidonic acid as part of a normal nutritional regimen. But for a lot of your folks, I think it has, arachidonic acid may have properties that help propagate or make muscle cells larger, or make advances in strength, and there could be, because that physiology, lifting and exercise has physiological signals that trigger the production of inflammatory response compounds, and that may be beneficial, or an adaptive mechanism. Some adaptive mechanism may be improving their physical performance based on that. And you're the kind of guy that I would call to figure that out. There was a study today. I get a feed from a guy every day on omega-3s, and a study out of London. It was a small study, but they fed people for 4 weeks with a fish oil dose, and then looked at muscle soreness after some rigorous exercise. And muscle soreness was down in people getting fish oil versus placebo. And then it was a really small study, though. But IL-6 didn't increase in the fish oil folks. And that's one of those cytokines, interleukin 6, that is one of the early telltale signs of your metabolic cascade to produce inflammation. So that was pretty cool.
Yeah, and IL-6 may, I think, have a biphasic response, that if you're a healthy person and lifting, you probably want it to bump up a little bit because of the inflammation of tearing muscle down and stuff, but then you don't want it to be like chronically elevated sky high either.
Yeah. So it's muscle cells are rebuilding right after after that causes greater mass. So inflammation, I think, can be our friend, but a lot of times it's our enemy. And with these COVID patients and people who are septic, I mean, their immune response is there. It's not meant to have, from an evolutionary standpoint, it's not meant to necessarily have medical intervention. That sounds really weird, but our bodies evolved with their own physiology and separate from medical care. So if you had a broken leg on a mountain and couldn't access anything, I guess that's your best shot,
Yeah.
But it's, this inflammatory response is just intense. And we see that when, you injure your arm or your hand or get a cut, redness and pain and all that. When you do it on a grander scale, hind limb injury models were used extensively to study inflammatory responses that killed people, and that inflammatory signal that can be distal to organs like the lung can have a profound effect on lung tissue, because in the circulation, all these hormone-like compounds, they roll around and they stimulate epithelial cells that get wonky and start having their own immune response, and that's how it starts. You have multiple systems organ failure, and they call it systemic inflammatory response syndrome now. So it's too much inflammation that causes people to get really sick, and a lot of those people to die. And that's what you're seeing with COVID. For some reason, with a lot of these COVID patients who get really sick, they respond much differently to other people. I don't know if that's a function of how many of COVID-friendly receptors they have or binding sites they have on their ACE2. The tissues are not. But so you've seen some of the therapies that have come out as old school steroids that actually work pretty well to treat people. So going back to basics, but in medicine today, there's soluble receptors for TNF and all kinds of anti-cytokine based therapies to try to reduce inflammation. And one of the dietary strategies to reduce inflammation is just eating a whole bunch more omega-3 or EPA and DHA in your diet, and that will mitigate some of that type 2 eicosanoid response that you see, or some of that inflammation you see. So
another reason for people to eat more fish or increase supplemental fish oil if they're trying to potentially reduce their risk of developing, COVID-like diseases or anything downstream from it. Yeah.
It's it's way too early to say for sure, but
sure.
There's actually been, I think there's 4 different companies that have omega-3 interventions, the EPA interventions in COVID patients. And one was a multi-center trial between Europe and the U.S., and a friend of mine from the particular company was working on that. So there'll be some interesting data in an acute model that will come out of this to hopefully give some more evidence on how effective nutrients are for real serious inflammatory conditions. So.
Yeah, I always think of what's the potential upside, which at this point super early, probably don't 100% know, and then what's the downside, right? And I mean, fish oil, EPA, DHA, I mean, it's been in the food. It's been around for a very long time. So I think we've got a pretty good idea that there's probably not much of a downside to it from a risk-reward type basis.
Yeah, it's, our FDA, I think we're up to 4 or 5 grams a day are considered safe now.
Yeah.
Which 4,000 or 5,000 milligrams. And the EU's 5,000 milligrams. So most people are eating 80 to 100 grams a day. So we're talking, just a few % of your dietary intakes. Greenland Eskimos that were living on a marine-based diet, Dieberg and Bang, the mean intake was about 16,000 milligrams of EPA and DHA a day in those populations.
Wow, it's 16 grams.
Yeah, right. So they're eating fish and whale blubber and, extreme, a lot of fat sources enriched in those fatty acids. But we did some studies on polar bears a long time ago too, and they had 30% of their phospholipids or EPA and
Wow.
DHA. Yeah, just crazy.
Why is that?
Seals. And,
Oh.
yeah, and the lack of soybean oil in the Arctic. But
yeah, there's not much else up there.
Their diet, their diet. But I was a younger scientist at the time when I was really intrigued by that observation. But we had worked on some hibernating black bears at the time.
Also, fascinating.
And in captivity, and so that was the other thing we were going to talk about a little bit was so we'll put COVID to rest, and if you've got aches and pains, try 30 days of 2,000 to 3,000 milligrams a day of EPA and DHA and see what it does for you as a take home on that. But,
nice.
But yeah, no, animals. So we talk about melting points of membranes and things like this. So those EPA and DHA are liquid at cold temperatures. So you can look at fish oil out in this -20 like we saw this past week in Minnesota, and it's still liquid, And if you looked at butter, it would be rock hard. So saturated fats obviously tend to be solid at room temperature, and polyunsaturated fats tend to be liquid at room temperature. So, and EPA and DHA are very liquid molecules because they have a whole bunch of surface area. They have a lot of double bonds that don't make their fatty acid chain straight. It makes it very kinky and disorientated.
Kinky fatty acids.
Yeah, I know, right? So, really neat. DHA is it's just it has tons of different conformations, which is from a biophysical standpoint just really fascinating. And that's what your brain, 30% of your fatty acids in your brain is DHA, and your retina, about 75% of the fatty acids in your retina.
Wow, I didn't realize it was that high.
DHA, yeah. So highly functional membranes have a lot of DHA, and muscle tissue does as well. We've done a bunch of tissue biopsy work for the military, and there's a whole bunch of DHA in muscle as well. So a colleague of mine, Steve Finney, had always told me that arachidonic acid and DHA in membranes was responsible for glucose uptake. So facilitated glucose uptake, and and in some athletes, we do see arachidonic acid real consistent among populations, but in athletes, we did some rugby players, and most people are 8 to 10% for arachidonic acid. These rugby guys were like 14 to 18%, almost twice. So I don't think they were consuming arachidonic acid, but I think it's that the functional aspects of muscle and glucose uptake in their muscles. But
interesting.
So but that's one little tidbit. But
that's one thing I look at in athletes too is arachidonic, and every once in a blue moon I'll see someone that's like really low in arachidonic, and again it's just completely anecdotal, but they tend not to be like the best athlete, and I don't know if that's just anecdotal or who knows, but it's something I've always just thought was interesting.
It could be from oxidative stress. It could be from diet. We looked at sled dogs, 2005 or 7, somewhere in there, and a lot of sled dogs. So the sled dogs are cool. They're running 100 miles a day during races, like
so crazy.
And 20-kilogram animal has about a 10 or 12,000 calorie a day burn rate, which is fascinating to me. But the dogs that do pass away, very few do, lots of good care now, but dogs that have passed away typically die from gastric bleeds. So we looked at that model as a way to look at the importance of arachidonic acid in these animals. Arachidonic acid is converted into a cousineoid that protects gastric mucosa. And, so we before and after races, in human cyclists, Steve Finney is related to Davis Finney, that was a famous bike racer. But they saw reductions in arachidonic acid in those athletes, and then positive fecal occult blood tests after long races, suggesting that there was some compromise, pre to post.
Interesting.
Right. So we looked at sled dogs, and we saw big reductions in blood levels of arachidonic acid, and then we took biopsies and gastric mucosa and saw a drop in arachidonic acid as well. So we called it exercise-induced or burn membrane syndrome, I think was the term that Finney came up with for that. But so there's a lot of oxidative stress. We burn about 3% of the oxygen we normally used to produce energy is converted into free radicals. And when dogs are producing 10 to 12,000 calories, it's a big number. So that swamps glutathione peroxidase and systems that are designed to take care of that. So that may be some of the observation with some of your athletes. So adding some kind of antioxidant regimen, or certainly food-based systems, if it's green or yellow or red and not artificial, it's probably going to benefits
the colors.
Mixed tocopherols.
Yeah. Huh.
So,
very cool.
Yeah. Anyways, a little side.
Yeah.
There's lots of lessons in life and extreme examples of performance. And I think that some of the work we did in sled dogs and some of the people that we met through that process was just incredibly interesting. So,
that's fascinating.
Yeah. The one we studied 5 or 6 mushers for one race. And one of those mushers was a First Nations guy, Inuit, and he fed his dogs predominantly seal. And those dogs had the lowest burn, if you will, or lowest reduction in arachidonic acid. Lewis Nelson is his name. But
was that because of the super high EPA DHA or a different component?
I think so. Yeah. I think so. Yeah. And one of the worst performers, great racer, but he fed kibble, a specialized kibble for his dogs. So with all the bells and whistles that modern pet food can offer.
Yeah.
So, but again, a very extreme situation in terms of physiology and metabolic demand. So, but pretty neat. So,
and I think you were saying cold weather or even cold exposure can preferentially convert to more DHA. Is that right?
Yeah, exactly. Especially for cold-blooded animals, snakes and fish, they remodel their membranes with largely with omega-3s with DHA. We use DHA and cholesterol. Cholesterol is a rigidifier for membranes, and omega-3s and polyunsaturates will actually make a membrane more flexible and more fluid because it's like an antifreeze. But we did some studies in hibernating gophers, University of Minnesota at Duluth with
Minnesota Gophers.
Yeah, right.
I couldn't resist.
And they had a Department of Defense study to look at thermal adaptation. And so Greg Beelman, who's a trauma surgeon in Minnesota, great guy, retired from them. He was a military doctor also, but he and Dr. Andrews worked on looking at hibernation in gophers, and they sent me adipose samples from hibernating gophers, and they were liquid. And I asked people when they're frozen, and I said, you must have sent me like plasma, and they're like, no, that's the adipose. So fat, on our own bodies is solid or semi-solid, obviously, but if you look at like a beefsteak or something like that, or chicken, you'll see fat in its normal state is not liquid. But so that was the first aha moment with those guys, and they had quite a bit of more omega-3s. They had a whole lot of oleic acid, which is normally found in adipose. But that's what animals use. These hibernators are examples of hibernating squirrels that we looked at in Alaska. Their body temperature gets sub-zero, just a little bit. But just remarkable models of physiology and adaptation. They heat up. We did studies with folks at the University of Fairbanks, the Arctic research group there. We just published a couple papers with them. But these animals will heat up every 20 or 30 days on a cycle to 38 degrees or body temperature. And I don't know, it must accomplish some kind of physiological aspect for their existence, and then they go back down. But they've had a temperature sensor in a female gopher up in the North Bank, and for 5 years now, and her plots over 5 years line up perfectly with time, and in such a cruel environment. That's sunny and warm for 8 or 10 weeks at the most, and then just brutally cold and dark the rest of the time. But so animals, humans included, need polyunsaturation. We need polyunsaturation for membranes to work correctly. Those long chain omega-3s, they interact with integral proteins that span membranes to send signals back and across the membrane. And then for animals, hibernating animals, it's turning out to be an important part of hibernation. So
Interesting.
Yeah.
So I have a freezer in my garage I've converted to cold water immersion at like
Yeah.
37, 38 degrees. So if I'm in there for a few minutes a day, do you think that's doing anything to convert anything? Or I'm not a
I don't
hibernating
know.
bear, so it doesn't matter.
Well, yeah. It's probably good for your cardiovascular system and
Yeah.
reactivity. I don't know. Yeah, to be honest with you, but
Yeah.
um, but yeah, we're warm blooded, so we have mechanisms to change those things. But
Yeah. I've always thought like the hibernating bears are fascinating. It's one of those areas I've never formally studied at all, but I've just been interested in reading the research, and partially because it's like living in Minnesota. You're like, oh, that's not bad. Like you're a bear, you just get real fat and fall,
yeah,
and then you eat everything in sight. You've got really interesting insulin glucose mechanics. You store a lot of fat. You crawl in your den. You don't exercise. The bear's not in there doing like bench press in the middle of winter or anything. And you wake up in spring significantly leaner with like very little muscle loss.
yeah.
It's like fascinating. It's like, how does that happen?
It's really neat. Yeah. Yeah. If your listeners, there's Arctic Biology Group at Fairbanks, and you can click on that link and see the people involved in all of that research. And I'm just a really ancillary part of that with my fatty acid stuff. But it's fascinating, and that's why salmon and trout and certain fish that we consume have a lot of DHA and EPA. It's because they're living in cold environments and they're designed to using those fatty acids to keep them fluid and keep them moving. So, yeah.
Yeah. Did you know Dr. Paul Azio at the University of Minnesota?
I don't think so.
Yeah, he was in the anesthesia department actually, but he spent some time studying black bears for more cardiac research. He worked for Medtronic and did some research for them too, because it's fascinating just like how low like all the systems just get super low and they're fine. Like there doesn't seem to be any ill effects, which is crazy.
Heart rate is 20 beats or something.
Yeah.
Just yeah. Beelman and Andrews, they produced a drug out of it with beta hydroxybutyrate and one other compound for treating people with shock related to bleeding. So,
interesting.
So something really positive came out of that. Yeah, it's in use. I think it's in use now. So, but so the government got a good investment out of that research. Yeah. So, fascinating. So physiology has a lot of adaptive measures, and the black bears we saw almost very low levels of DHA, and it just spiked 3-4 weeks into hibernation. These are in captive animals as well, so just internal mechanisms to produce DHA really kicked in. So quite cool.
Interesting.
Yeah.
My uncle lives in Alaska, and so we got to go up there maybe 7 years ago now, and he's just outside of Homer. And he used to spend many years working up in northern Alaska, a lot of the indigenous populations putting in running water to a lot of small villages that were there.
Yeah.
And it was interesting just talking to him about stuff. And he said, yeah, when whaling happens, like everything just shuts down, right? Because that's like the thing, that's their whole, subsistence, which makes sense. And so I was asking him, I was like, well, what else do they eat up there? And he's like, well, they put seal oil on everything.
Yeah.
And I'm like, seal oil? I'm like, how does it taste? He's like, they loved it. He's like, I thought it was horrible. And I'm like thinking, seal oil? Why was seal oil? And then I looked, and what you mentioned was seal oil is like ridiculously high in EPA, DHA.
Yeah.
Right? So like their diet, they're just getting skyrocketing levels of EPA and DHA.
Yeah. Yeah. I've been to Alaska a few times, and I was on a little island in the middle of nowhere. I can't think of the name of it. Was it Cook but they had a farmer's market, if you will, and several people had seal oil out.
Interesting.
Seal oil out that you could buy, and some was pretty clear and looked good, but some was really brown and really oxidized and looked like something I would make. But I found a cookbook there too, and it was, I don't know, from 50, 80 years ago, but almost every recipe had seal oil as part of it there. So I mean, we live in the Midwest where soybean and corn are grown as our main food source, if you will, from the plant standpoint, and we use the oils from those. And in the environment these people live in, it's seal was the most abundant supplier of oil and fat. And they had lamps, seal oil lamps as well. So it was there. Calories are important when it's minus 30 and working all day.
Surprisingly, like one of the earliest studies you talked about too was that their cardiovascular risk was super low. And this is like back for context for people listening. This is like back when we thought fat was horrible.
Yeah, it was,
we thought, oh my gosh, these people, their cardiovascular risk is going to be astronomical, and it was like the inverse, I think, of what we expected.
Yeah, Greenland Eskimo research. Yeah, Ansel Keys at Minnesota was saying fat's going to kill you. It raises cholesterol.
Summit Country study.
Yeah, and so the folks in Greenland were eating, 60-80% of their calories as fat and had relatively low incidence of cardiovascular disease. So that was one of the big aha moments. And they actually came to my predecessor's lab, and they didn't know what these two huge peaks were in the chromatogram, EPA and DHA. So we had Ralph Holman had a guy named Bill Christie who was a really smart analyst, and he said, "Oh yeah, that's EPA and DHA." So
wow,
those weren't known at the time, but that's quite some time ago. But
interesting.
Yeah. So fun tidbits, but yeah, they were one of the extreme examples in life give us a lot of big clues because they really push hypotheses like the sled dogs or Greenland Eskimos, and we learn from that. So, and COVID may be one of those things that teaches us a lot. It's a horrible thing, but it could be a silver lining that we learn a lot from it. So,
yeah. Do we think that like even people in that area, because they are so almost hyper adapted to an environment that's cold and has super high amounts of fat, that once they get exposed to more Western diet, which has a lot of deleterious effects, they unfortunately seem to do worse, it seems. Is that correct, or what are your thoughts on that?
Yeah, no, it's very much true. I mean, your genetics are what you're exposed to, and nutrition has that as well. Lots of examples of the westernizations of First Nations people in Canada that resulted in incredible amounts of obesity.
Yeah. A lot of diabetes.
Yeah. So there are folks that just didn't see a whole lot of carbohydrate in their life, and then when you amplified refined sugars and things that were metabolized, you store it, and so there's a lot of sad lessons from that. But there's a CBC documentary, Canadian Broadcasting Service, that talks about some of that, and I think it was a friend Jay Wortman was one of the authors of that. But good show.
Yeah, and for research, people can look up the Pima Indians. Also, they've been fairly well documented and studied in terms of the effects of high processed diets and glucose and insulin resistance and that kind of stuff too.
Yeah, I learned a few weeks ago. I had a call from a guy on the East Coast, and I learned about native agricultural practices that are having a comeback in terms of producing food and health benefits of native-based farming. So there's a renewed interest in practices that help cultures span hundreds or thousands of years in our development. So
there's a guy, Sean Sherman, here in Minnesota, who's gone back and looked at for just cooking, just a phenomenal chef. Like we had some food he prepared up north and it was like amazing. But he's gone back and looked to see, well, what were the practices like? And it was very hard. He spent a lot of time trying to document it. And so he's working, I think he's opening a restaurant hopefully this summer that will feature a lot of that type of cuisine, which I think will be super interesting.
Yeah. We worked a little bit with some groups in Minnesota, native groups, and we tried to compliment them really that the practices they had were actually very healthy, sustainable. So it'd be neat to see that come around more. And the paradigm's always changing, right?
Yeah.
I do like the fattier cuts of beef or pork that you can find in restaurants.
Yes.
So some of those traditional duroc and things like that are fantastic. So
yeah. Cool. As we wrap up, just a couple more questions here for you. So I want to be respectful of your time. Sure. Is it possible to get too much EPA and DHA? I mean, especially now with, supplementation becoming, more and more concentrated. There's, we'll say, older people in the strength coaching realm. One coach in particular was popular for just massive amounts of fish oil seem to solve everything, but
Sure.
I would imagine at some point that you're going to start to see detrimental effects, or would you just have to be so bonkers you're probably not really going to run into that?
Yeah, I mean, there's biochemical constraints in membranes. Phospholipids have two fatty acids that hang down, and only one of those will be polyunsaturated, generally, except for extreme cases. But so you can only get up to about 50%. So there's saturation that's going to happen, and I imagine you just oxidize the other fatty acids for 18
Going to burn it off, so to speak.
Yeah, right. So there was one client of ours that did 40 grams a day. I think you know him. And
yes, I know him.
He was disappointed. His results were super high.
Yeah,
but they weren't like way off the charts.
Yeah.
Because because of how membranes work, and that's just the max that goes in there by design. So. But I never thought anybody would do that until talking to this individual. So again, another teaching moment. There's so Greenlanders did have a tendency to bleed longer.
That was my next question.
And clinically, that's with 16 grams a day, eating half a bottle of fish oil a day.
Yeah.
We have a tendency to clot too much in our culture with North American diets today. So dialing that back a little bit, I think, is beneficial. Excessive consumption may abrogate some bleeding, but it's not. It's the papers we talked about. There's never been a documented case of surgical bleeding related to fish oil. Some of it's overblown in terms of bleeding risk, but
that's what I was going to ask too, because I keep looking for case reports, because it's like, okay, so your INR may be changed. Okay, so is it one of those things where statistically it can happen, so you do see a change, you do see a longer clotting time? Yeah, but at the same point, like if there were, with how ubiquitous fish oil is and people consuming fish, and there was a massive bleeding risk, we would find just tons of case reports in the literature by now.
Japan would be in trouble.
Right, yeah. Countries, especially Greenland, Japan, they would be all reporting massive issues.
Yeah. And that's the clotting is regulated by the cousineoids and leukotrienes of these hormone compounds, largely these hormone compounds from fat. It's safe. And if you're concerned, you can talk to your physician. I doubt they'll know much more than you can find out yourself. But
Yeah. And then you had mentioned once, I think several years ago, that farm-raised salmon and some farm-raised fish, especially salmon, I think you had mentioned, there was a published study I found too that you had pointed me towards, that EPA and DHA levels were unfortunately quite low in them. Is that correct?
Yeah, they were down quite a bit. So they're in farmed salmon. They used to use fish meal and fish oil to produce those animals, or those fish, not animals. But and then they switched to canola oil largely, and so 18 are plant based with a lot of omega-6. And the net of that, the net was a reduction in the percentage of EPA and DHA, but they have a ton more fat. They have a lot of fat in those fish now. Funny, fish raised on vegetable sources tend to produce more fat, if you will, or fattier, and so they're very different from wild type. So they have much more omega-6, and their omega-3 is about the same because they have 3 times more fat than a wild.
Oh, interesting.
Animal. So so
the EPA DHA went down, but because they have so much more fat, the sheer number is actually more equivalent.
Right. And a colleague of mine described it as, the equivalent of hamburger. So and there's an example of fish didn't evolve, consuming plant-based, or not, that's a wrong statement, but, canola oil necessarily in their regimen. So there's a big difference. But, that said, wild fish is the best if you can eat it and afford it. It's incredibly expensive for a lot of people. So there's aquacultural sources as well. And you'll just see, aquaculture is just growing and expanding as a way to offer protein to a growing world. So we add about 1 billion people to our world every 10 to 12 years, and that billion people consumes the same amount of protein that's found in the U.S. soybean crop produced annually. So it's not as apparent right now, food insecurity, but as our world grows, it's going to become more apparent. So, and farmers markets are great places to buy farm raised meats, and we buy pasture raised chickens. I grew chickens on my own for fatty acid experiments, and the taste is amazing. And it costs a lot more, but it cost me about $8 a chicken to produce them without labor costs factored in. But so that's the they're more expensive, but I think you're getting a much more fulfilling and healthier bird if you can afford it. And we buy all our pork from farmers markets and private producers, and try to buy beef from those folks as well. So grass-fed animals tend to have just more omega-3s. There's not a ton in beef to begin with, but they tend to be, I think, a healthier choice if you have the option. So, but support those little farmers and local farmers. Yeah. So.
Yeah, we try to do that as much as we can too. We actually just got from another farmer in Wisconsin. He had someone who canceled their order. So we're like, yes, we'll take it. And he showed up at our door yesterday, which was awesome. And he dropped it off. And I'm like thinking, oh man, are we going to fit this all in our 2 freezers? And we had to take everything out and restack it. And we got everything to fit just barely. So it's nice to be stocked up.
That's good. Yeah. And then that farmer, I'm sure, really appreciated it too. So that's.
Well, yeah. And plus, I mean, it's got to be a hard go doing that. And I talked to him about it, and even just, their margins are not really super high, and most of the people I know doing it just do it because they love it and they think it's a better way. And if I'm in a position where I can support them and get high quality meat out of it at the same time, it's a win-win.
Yep, and there's a definite taste difference that I find. So especially in chickens, and I get to Mexico some, and we buy chicken down there, and it's the adipose is super yellow, that has lots of carotenoids. So I know they've been ramming around in the countryside eating bugs, and the chicken just tastes amazing, and it's because it's fed a diet that's probably more wild than anything, So.
Yeah, the eggs are like that. The first time I ever went to Baja, we went down there kiteboarding years ago, and we're in La Ventana, and just small place, and it's all markets, so people sell their eggs and stuff. And so we got up in the morning, made an omelet, and I cracked this egg in there, and like the yolk is like glowing orange. I was like, holy crap, look at this.
Yeah, they taste wonderful. Yeah.
Oh, it was amazing. Yeah.
Eggs are good food. So that's there was a recent study that showed reduced cardiovascular risk with increased egg consumption. So
oh, nice.
I'm sure you do. But the old myth that eggs were dietary cholesterol was such a horrible thing. Finally being exhausted. So
Cool. Last question. So I think if you were to make just a broad speculation based on the research, 2 to 3 grams of EPA DHA, do you think that's a reasonable amount without knowing too much about diet intake or maybe consumption of a higher fish meal 2-3 times a week?
Yep. Yeah, it is. And that's based off of hard science. Bill Lanz had a giant in our field, had a study in BBA in 1989 that actually looked at intake and output in blood lipids. And he has a calculator. You can go to efaeducation.org. There's a calculator there that you can use to calculate how much you need to get to a blood level.
Very cool.
So, but and you can take a blood test with us, obviously. Yep. But to get to that balance, that 50-50 balance that Bill Lanz talks about, it's about 2,000 milligrams a day for most people in the U.S. So if you're a bigger human or you're really active, I would push more towards 3,000. You can certainly get an omega-3 blood test from a variety of peoples that'll give you that and that number as well. So
and we'll have all the info in the outro for your blood test info, and people can get more info on that, which is great.
Yeah.
And do they have to take spread out over the day? So if I'm taking like a supplement and I'm taking a gram per dose, should I take it with 3 meals, or could I take it all at 1 meal, or does it matter?
You can take it with 1 meal, but there is some data that suggests that splitting it up 3 times is good for production of protectins and resolvins. So if you're disciplined enough, the most important thing is to make sure you get that dose in every day. But if you're disciplined enough, take it throughout the day with your meals too. So and taking fat with a meal helps digestion and absorb most of it as well. So Yep. But it's just really important to try to get into that daily routine, because you can slip a lot of times and then it just goes away for some folks. So,
Yeah.
but there's a lot
Awesome.
of concentrates on the market now too. You can buy that'll have, 500 to 900 milligrams per capsule. So 3-4 capsules and you're good to go. So
Yeah, they've come a long way with it being a lot more concentrated than 15
yeah,
years ago, where it was like a whole bottle to get a couple grams sometimes, depending upon what you bought.
like a dozen capsules of regular fish oil.
Yeah.
Now I think I take 6, and they're 700 milligrams each, so I get 4.2 grams about that. So, but that's my strategy. So
Yeah. Awesome. And where can people find more information about you if they're looking for just information or possibly consulting or other things that you do?
yeah, our website is lipidlab.com, and then our blood test is omega3test.com. So our new website for that should be up in about 4 weeks. So we're working on that right now, but there's a splash page there right now. So
Cool.
yeah,
Awesome. Well, thank you so much. I mean, I've been using your test now for, God, almost over a decade, and I still use it with all my clients and stuff, and it's been super useful, I think, because it's one thing to say, yeah, you probably need more omega-3, and I can look at your diet and get a rough idea of where you're at, but it's a totally another thing for them to look and see where their levels are, to look at their omega-6, some of the other values, and I think there's something about having the actual number and then telling them that, hey, if they're really bad off and I'm not so sure they're kind of down with the fish oil, I'm like, I'll pay for your test and I'll do it again in like 3 months, right? So something to think about them knowing they're going to be tested again. Oh, it kind of helps drive compliance too.
Yeah, and that's the cool part. 30 to 60 or 90 days, you can retest and see if what you're doing is working for you. And we've done that with a lot of athletes, a lot of Olympic athletes. We're doing it with some special forces people right now as well. So that test really allows you to dial in if you're darn serious about what you do. But
yeah,
but
the nice part is it's an at-home test too. So you just mail it out. People can do it at home. They don't have to go in. They don't have to donate blood or use an IV or anything like that, or get a phlebotomist. It's kind of nice. You can do it at home and mail it in, and they'll get you the results, which is great.
Yeah. It's been a useful tool. So. But thank you. Appreciate talking to you today.
Yeah, thank you so much for all the great info. I really appreciate it, and I always appreciate all the help throughout the years. Whenever I get stuck on omega-3s, I'm like, I got to ask Dr. Doug. He'll know.
And likewise for physical performance and everything.
Oh, sure.
So yeah. So all right.
Cool. Well, thank you so much. I appreciate it.
Thank you. Take care. Have a great weekend.
Yeah. Thank you so much for listening to the podcast today. We really appreciate it. Big thanks to Dr. Doug for taking time out to do the podcast, as always. I mentioned at the intro that I've got a crazy offer for you. So I talked to Dr. Doug, and I wanted to promote some of the testing that he has that I've used for quite a while and really like. I don't get any commission off of this test other than the disclosure I have is that I do use it with my clients. So if you go to omega3test.com, that's with the number 3, OMEGA3, TEST.com. So omega3test.com. The regular price is around $165. And he said for a limited time, anyone who listens to this podcast will be able to get it for just $30. So that's not $30 off. That's a total cost of $30. The key is you have to type in the code there, Flex Diet, all one word, FLEXDIET.com. Type that in on the page at omega3test.com. And for a limited time, you'll be able to get the entire test for $30. It's normally like $165. It is limited. We don't know how long this will go for, but go there today, type it in. I don't have any disclosures. I don't make any money off of that particular test there, but I wanted to do it to help promote his testing, which has been super helpful to me. So make sure you check that out. Big thanks to Dr. Doug. And as always, it's also brought to you by the Flex Diet. Go to flexdiet.com, FLEXDIET.com, and you'll be able to get on the wait list for the next time that it is offered. Also puts you onto the free daily newsletter. Thanks again for listening. Really appreciate it. Any reviews, comments, anything else, subscribe, all that stuff. Always appreciated. Thank you so much. Talk to you all soon.